Hello everyone, I'm Xavier, I'm SRE in France, and today I would like to introduce you affinities inside Kubernetes. So this is a dedicated topic inside our Kubernetes training. So this is a playlist that you can find inside my YouTube channel, and affinities is really important in fact in Kubernetes because you can use it for a lot of use case. So we will discover that today. Why to use affinities and what is affinities. So this is the purpose today. Some use case, sometime for example, you want to ensure that your pod will be deployed on a specific node, because on your Kubernetes cluster we can imagine that you have, for example, if you practice AI or LLM inference or training maybe, you probably will have some node with GPU on it. So maybe it's a specific GPU with some driver or just GPU, and you have a side of it some node, classical nodes with just CPU. And probably for some nodes, you want to deploy it only on GPU. This is where affinities can be used. So in affinities, you have what we can name topology. So it's really, really important, as you know. There is some other use case, of course. For example, you have two components, front-end, back-end, and you want to reduce the latency between each component. And probably you want to deploy the front-end and the back-end maybe on the same node, but not on the same node for the reliability, but probably in the same zone if you use like classical cloud providers. And if you want to do it, probably you will want to set affinities to mitigate that with what we named the pod affinity. So we have two kinds of things. We have the node affinity and the pod affinity. We will discover that in this video. In the next video, we will discover a demo about that to well understand how it works. And the other things is maybe so we want in some times to reduce the latency to ensure that component front-end and back-end is like not really far one regarding the other. And in some other case, probably we want to be fault tolerant. So to ensure that one instance about our service for a dedicated service, we want to ensure that this service is spread over multiple regions or multiple zones. And to do that, we can use again what we name the affinity. So affinities cover topologies and cover like thing about how we want to spread pods. Maybe sometimes we want to have affinity, so to have pods deployed regarding some other pods, but maybe we want to have anti-affinity, so we don't want to have the pod at the same place or with the same spreading regarding our Kubernetes cluster. So if we want to sum up that, we have three kinds of affinities. So affinities is the pod placement, maybe regarding the node affinity, so based on the node labels. So we can have a node labels based on the zone, on the region, or maybe on the hardware, like we said. Or we can have pod affinity. So pod affinity is just to say, okay, I have the pod name A and the pod name B, and I want to have a pod name B deployed close to the pod A. So this is the pod affinity. Or we have the pod anti-affinity. So the purpose is to separate pods in a group. So we can say, okay, we have a group, maybe based on a single deployment, but maybe that could be a group based on a dedicated label. I can say, okay, this label is fronted. Into this fronted label, I have the deployment A, deployment B, C, or other, and I want to ensure that all deployment inside and all pod inside this deployment is spread based on the group name, but based on a topology key. That can be the host name, that can be the zone or region, and this is what we name the anti-affinity. So some details inside each kind of affinity. Inside each kind of affinity, you have, or in each kind of affinity with node affinity, pod affinity, and anti-affinity, we have two kinds of scheduling. There is the required during the scheduling, ignored during the execution, or preferred during the scheduling. The first one, of course, it's required, so that means that if you select this one, you have a strict equality, so that means that your condition need to be checked to deploy your pod. The second one, like you can imagine, it's a preferred. That means that this is not a strict condition, meaning that based on a weight, on some weights that define a rule, we can deploy a pod even if we haven't a strict condition checked. So if we sum up, we have the node affinity with required or preferred during the scheduling, pod affinity required, preferred, and pod anti-affinity with preferred, and required. Take care, each time it's during the scheduling. What it means? It means that when the scheduler inside the Kubernetes cluster, like we already saw in the previous video at the beginning of this playlist, we said that we have the scheduler component inside our Kubernetes cluster. We have two phases into the scheduler. We have the filtering and the scoring. And during the filtering things, we can check if conditions are checked or not. If these conditions are validated, we can ensure to deploy with our rules, so with our affinity in this case, for example, based on the node affinity, pod affinity, or anti-affinity. But it's only, this is why it's into the key about our setting, it's only during the scheduling, meaning if you have the rules well defined on the node, for example, for the label, and in the deployment or in the pod settings, you can apply and ensure that this condition or these conditions are checked. But if these rules are changed after the scheduling, for example, on the node side, we can imagine we have a node with a label, and our pod are all already deployed. If we remove the label and the affinity is based on this label, no things will be changed. We keep it in place, even if we check manually that we have some pods requiring the label, like EU West 1, for example. So if we remove the zone on the node side, we will keep our pod on it. But it's during the scaling, meaning if you, for example, downscale and upscale again, you will reset the scheduling, and that our condition will be rechecked again. Okay, so for just we can zoom into the node affinity. Into it, so we have condition that we want to check, even in the preferred scheduling. Here it's for required, but we can use it for preferred scheduling. And into it we can use the match expressions, meaning it's based on the node labels, because we are on the node affinity, or we can use what we named fields. So this is the match field based on metadata. For example, if you use the node affinity, maybe you want to check that the node name, so it's metadata.name, in fact, and you can use this metadata into the match field. As an example, for the node affinity, we have like match expression or match fields, like we said, and into it we can just set multiple conditions. But if we are into this indentation, like here, in the match expressions list, we can set a lot of key into this list, but it's like hand condition. So it's a cumulative condition. So we need to check all conditions are true, are verified to ensure the node affinity. And we have a key, we have an operator, like you can see here, the operator can be does not exist, exists, or greater than, in, lower than, or not in. So this is a classical condition like you can find inside some language like Python or stuff like that. And after that, you have values. So this is a list of values. We can have only one value or multiple values. Same thing for the match field. We have the key, but here it's a key. It's not a label like here. Region could be a label, but here it's a key. So this is a metadata because we are into fields. So metadata.name in and the value, and we can have multiple values into it. Take care about the indentation and the usage of these settings, because if you can set multiple match expressions like here. We can imagine here it's not match field, but that can be match expressions as well. So you can have multiple match expressions with only, for example, one key into each match expressions, and in this case that will be considered by the scheduler with a OR. That means that only one condition need to be checked. You can cumulate match expression with match fields like here. In this case, if we want to translate that, the node affinity will check if to deploy the pod, if the key region is in US East, or if the metadata name in the list of node 3. So meaning either we could deploy inside the region US East or on the node 3. So you can imagine that we could have a cumulative condition, so we need to check all expressions. Like here, for example, we have only one key match expressions, or we can cumulate or and of course, like classical condition, but just to imagine only one expression. And if we want a cumulative and to ensure all conditions are checked, we can set multiple key like here. So region is in US East, like on the left, and like like on the left again, we can set, okay, we want a host name, but we are in the match expressions again in the values key 0SC5, meaning that we need to have a node name K0SC5, and in the same time we are in the region US East. It's a classical thing. So if we want to check, if we take the left values like here, we can imagine we can deploy on the US East because we are with the OR on the left condition here. So our pod will be deployed on the key 0S2. But if we are on the right condition, like here, with cumulative with a hand, we will have only our pod inside the key 0s SC5. And if this node will be node 3, even if this one, we can imagine on the left condition, we can imagine our deployment could be on the key 0s2 and on the key 0s5 because all nodes are in the region US East for each one, so it's set on the label directly. Okay, so now the pod affinity, it's quite not exactly the same thing, but it's the same logic behind that. We have the affinity. This is the pod affinity, not anti-affinity, but it's a pod affinity required during the scheduling, so it's a strict condition, strict checked. We have label selectors, so it's how we want to check things. So we are based on label. We want to check the label with app backend, and all pod with this kind of label will be in the same group and with the same affinity that we will set here inside this pod, of course. So we can imagine this pod, so we are in the pod with the label frontend, for example. So we have into it, for example, multiple replicas into it. And we can imagine that we want to have our frontend in the same place and on the same name as our backend. So in our pod, our front-end pod, what we can say, what we can do, we can set the pod affinity with a required like that. We can say, okay, our front-end need to have an affinity based on the label to ensure that our front-end will be with another label app backend. So this is like a group. And how to ensure the granularity of our check, it's on the topology key. Here it's on the host name. If we want to just well understand this thing with a schema, this is like here. So we have the topology based on the host name here, key 0SC1, 2, or 5, and so on. And after that, we have our front end with app label set to front end, and just aside of it, we have another kind of deployment with a label app backend, and we will use the same topology, so it's host name, and we will ensure that front-end and backend will be associated on the same host name because we use the topology host name. So this is the kind of affinity where we want to have one application close to another front-end with backend. So this is just an example. Here, the topology key is like a partition key, in fact. Into it, you have the required, but you can have the preferred. So it's a little bit different. For preferred, you need to set the preference based on match expression or match field, like we already saw. And you need to add the weight. So this is a ponderation from 1 to 100. It's not a percentage, it's more like a priority. So with 100, you will want to have like a strict condition, but not exactly a strict, but a really well-checked condition. If you set 1, of course, the condition not be really strict and just only preferred. If you want to have a look how to set the affinity in details, you are on the Kubernetes cluster, you want to check how to set it, you don't remember how to set it exactly because we have like a long key with a multiple key with multiple level layer, and you can use kubectl explain the pod.spec.affinity -- recursive, and you will see stuff like here. Of course, you can use kubectl explain for all resources, not only the pod, and not only, of course, on the affinity. So that's it for today. And remember, here we just checked the affinity. You can do exactly the same thing with anti-affinity, meaning that here, if we use anti-affinity, the same thing based on host name, but if we just change here affinity to anti-affinity, we will have front end on different server, because we are based on host name, than the backend. So this is totally the opposite. So in our case, if we will have the anti-affinity, we will have front end on one server, but back end on in another server, and this condition will be checked, of course. That's it for today. In the next video, we will have a demo, and maybe it could be better to understand this kind of things. And yes, see you in the next video. Don't hesitate to subscribe to the channel to not miss this one. Like and comment this video to support me, and bye bye.